The level design workshop at this year's Game Developer Conference chock-a-block with great talks and roundtables, including a very special presentation from Bungie about how to build levels that appeal to a variety of player types. World design for different player types, presented by Bungie Design Light Railing Deck, aims to dig into practical ways to build worlds that your players will love, while also leveling up your world designers by learning how to focus on what matters most. This is the place to be if you want to only aim practical ways to tailor your levels towards player motivation through concrete examples from franchises such as Mass Effect, Dragon Age, and Bungie's on Destiny. You will also learn how to think about what's most important in your game based on your intended audience, so you can spend your limited time building that instead of something your players will not value. To learn more about this great talk and all the other cool sessions available during the level design workshop, make sure to check out the 2019 session scheduler. There you can begin to plan your GD 2019, which takes place March 18th through the 22nd at the newly renovated Moscone Center in San Francisco. For more details on GDC 2019, visit the show's official website, or subscribe to regular updates via Facebook, Twitter, RSS. Gamasutra and GD are sibling organizations under parent company Informa. The Gamasutra job board is the most diverse, active and established board of its kind for the video game industry. Here is just one of the many positions being advertised right now. Location: Barcelona, Spain. Responsibilities, requirements, assets. Why join the world of Gameloft? What can Gameloft Barcelona offer you even more? Interested? Apply now. Whether you are just starting out, looking for something new, or just seeing what's out there, the Gamasutra job board is the place where game developers move ahead in their careers. Gamasutra's job board is the most diverse, most active, and most established board of its kind in the video game industry, serving companies of all sizes, from indie to AAA. Looking for a new job? Get started here. Are you a recruiter looking for talent? Post jobs here. In the following essay, the leading technical artist of Neki's Russian development partner Bungie Games, Roman Tursky, describes the rendering process and the materials used for the characters' equipment in the mobile game Shadow Fight 3. In addition, he reviews some of the tricks used for setting up the environment. Shadow Fight 3 is an RPG action game developed on the basis of the Unity engine. The game was released on iOS and Android in November 2017, and since then the number of installations has exceeded 50 million. To reach such a large audience, the development team had to perform well in optimizing the game, and as a result of their efforts, the game runs at 60 frames per second on most modern devices. Journalists and players often praise the visuals of Shadow Fight 3. In this article, I will give you insight under the surface of the game and reveal how we managed to achieve this visual quality, rendering a frame. There are many factors that directly affect the performance of the game and the number of frames it can display per second. One of the most important factors for us was the number of jaw calls used per one frame in the game. Let's take a closer look at the concept. During the rendering of a game frame, of each static group of objects sharing the same material, Unity uses jaw calls and overlays them on each other. Each jaw call requires CPU resources, so an important step in optimization is to reduce the number of these calls. Our goal was to minimize the number of calls to 100 per game frame on average. This GIF shows how a single frame is rendered. The first step of rendering in Shadow Fight through is drawing the dynamic shadows of the characters and the glow effects for the luminous elements on the armor and weapons of the characters. Both of these processes have their own peculiarities and they should be explained in detail. Shadows, in addition to the main camera used for the main frame, an additional orthographic camera projector is installed on the scene, designed to draw the shadows from the characters onto a separate surface we call a shadow receiver. This camera follows the midpoint between the opponents and creates their projection onto the plane based on their current position. The result takes the form of an alpha texture, which replaces the same texture with the render result of the previous frame in the dynamic material of the shadow receiver object. This approach helps us to avoid the need to calculate real shadows and draw them on all models in the location, which would have a significant effect on the overall performance. Shadow receiver surface. For this frame, the process took 20 render calls. Glow. The process of creating a glow effect on the armor and the weapons of the characters is similar to the process of creating dynamic shadows. A blur cup is created around the model with luminous elements. Glow effects are projected on its airframe based on information stored in the blue channel of the RGB texture of the material of the glowing object. That means the blue channel acts as a mask projecting the glow. You will see more about this below. In the section about character materials, the blur is applied and the information is saved as an alpha texture, which replaces the texture with the result for the previous framing. The dynamic blur cup material. Blur cup. In this frame, the glow process calculation took 15 draw calls. Please do more to blur the effect. Much is done. First of all, the parts of the armor and the weapons of the characters are rendered, and we render all parts of the location of the foreground, then the background objects, and then the background itself, which is a plane with a texture size of 1024 x 512. They are followed by particle systems, some small details of the foreground, and, finally, models using a text animation. More on this below. Eventually, in the next two draw calls, the calculated and previously drawn shadows and glow effects are applied. UI. In addition to the cameras mentioned above, we use another one during our rendering process, which is intended to render the user interface. Unlike the main and orthographic camera projector, it is not unique for each scene. It exists permanently during the entire game session. Thus, after rendering the scene, the characters, and all of the visual effects, UI is rendered and placed on top of the main frame, all along with the dark vignette on the screen edges. Main camera render, UI camera render, final frame render. In total, the rendering of the final frame of the scene required 92 draw calls for character's equipment material. To create the material of the character's armor, a few textures with a resolution of 512x512 are used. Diffuse, RGB masks, matte cap, an additional diffuse map for the shadow form, as well as a small noise texture marsh mask used to create the effect of the character's transition to the shadow form. Diffuse map is just a texture of the armor itself. So let's discuss the rest. Since the RGB texture conventionally consists of 3 color channels, defined by the value 0 or 1 for each pixel, it is convenient to use it for storing various data about the material at each specific point of the map of the object. In our case, the RGB texture channels, masks, contain information for the following processes. The red channel indicates which elements of the material will change their color if the opponent's character is wearing the same armor. We use this system so that the player does not confuse his character with the opponent. Certain parts of the armor set in the red channel are repainted to the opponent's alternative color, which was set by our artists. Green channel is used to indicate which elements of the armor the madcap texture is applied. For us, madcap texture creates a metallic surface effect, and the magnitude of the effect is stored in green channel. As well, the lighter the texture, the stronger the metallic shine. Blue channel contains information on which parts will use glow to simulate a luminous surface, in order to create a reflection effect for the metal elements of the armor and the weapons of the characters.